Welcome everyone. We got a couple folks still flowing in, but we'll go ahead and get started. Welcome everyone to latest installment of Atomic Friday. I'm Keith McCammon with Red Canary, joined here by two friends to talk about a number of topics that I think are kind of near and dear to everybody. Before we get started, wanted to handle just a couple of administrative items. As always, this is being recorded, and the recording will be sent out to everyone attending, and shared publicly for anyone who wasn't able to make it today. If you have any questions, I know Brian mentioned in the chat, just put those right in the Atomic Red Team Slack channel, and we'll be keeping an eye on that during and trying to field as many of those as we can get to throughout the discussion. So, without further ado, going to dive right in. Again, my name is Keith McCammon. I'm with Red Canary and have known both of these gentlemen for some time. My background with Mauricio, who is our special guest today. I think we go back probably 7 or 8 years or more now, and I recall fondly meeting you. Kind of talking through. This is the very early days of Red Canary. We're still trying to figure out, what we were going to do, how we wanted to focus, and we had a bunch of ideas and opinions in terms of how we wanted to approach detection in particular, detection engineering and like coverage and some of those kind of concepts that we want to get into during the discussion. And I've always remembered finally that first discussion where I felt like we were just kind of very much in sync. You just had a really collaborative approach to security in general, and also kind of, a lot of overlapping ideas in terms of how to implement this stuff, both inside a single organization, but also at scale. So I'm looking forward to the discussion. Before we do get to Mauricio, would love to just give Matt a moment to introduce himself, and then we'll keep it moving.
Sure. Thanks, Keith. I'm Matt Graber. I'm also at Red Canary. I'm the Director of Threat Research here. So I don't want to talk too much about myself since Mauricio is our special guest here. I'd rather just talk about him. So I had the pleasure of meeting him last year at B-Sides Charm in Towson, Maryland, and I'm based out of Maryland. So it's my first time going there. Amazing local conference, which I'm sure Mauricio can attest to, having been there twice now, I think. But he gave a talk there that really stood out to me, and it was really the highlight for my time there, aside from meeting great people. His talk was called "Embrace the Red: Enhancing Detection Capabilities with Adversary Simulation." And at least from my perspective in history, this was my first exposure to anyone else, really trying to think through and formalize what it means to define detection coverage. And it was really eye-opening and validating in the sense that I had personally and through previous orgs where I worked, really starting to think through not only the detection engineering methodology, but just how we can think about maximizing striking that right balance between breadth and depth of coverage. And Mauricio's talk hit the nail on the head for me, and really clarified a lot of concepts for me, and how he was able to not only take his philosophy and put it into practice with great demos and just really well engineered code. Sort of blew me away. And then we started talking, and relationship kind of blossomed from there. And I consider him a very good friend. So with that, I'll pass it off to you, Mauricio, and why don't you go and introduce yourself, give a little background, and take it from there.
Yep. Thanks, guys. I appreciate the kind words, both of you. So I'm hello, everyone. I'm Mauricio Velasco. And I currently lead the threat management team at a Fortune 500 financial services organization. My team has been focused on detection and response and adversary simulation for quite some time now. I've been I've been doing some talks and research and tools, releasing some tools around these topics. So at some point, I'll share my GitHub. So if you are interested about that, you can look at them. And I'm really happy to be here. My first Atomic Friday as a panelist, at least. Especially with two folks that I greatly admire and look up to. So thanks for having me. Thanks for the kind words. Fun fact, Keith was one of the first people in the InfoSec industry that I met here in the US when I moved a little bit more than 8 years ago or 7 years ago. So yeah, we go a long way, and I've been close to Red Canary and the awesome work that they do. So again, really happy to be here, really excited to be able to share this conversation with you guys, especially about a topic that I'm really passionate about and I've been thinking a lot about and working a lot about. So yeah, looking forward to this discussion, guys.
Cool. Thanks, Mauricio. So why don't we start by just establishing like what the problem is. Like let's get a problem statement out here. So what, in terms of like detection coverage and with your work in Purple Sharp, what are we trying to solve here?
Yeah, that's a good question, and I think I'll go back to answer that question. I want to go back just like some stories that a few of you guys have probably dealt with if you're part of a SOC or response process or leading a detection program, working on a detection program in general. And let me give you a story. One of many. We are, a few years ago, we were looking at the threat landscape. We were getting hit by a campaign. I think back then it was Drydex, if I'm not mistaken. But anyway, we identified an interesting TTP, and since then it's become really wide known and probably it's their norm now, which was a simple word macro, calling PowerShell and downloading a binary. Back then it was kind of new. So we used one of our tools to build a detection for it, and it was simple, a simple parent-child process relationship. An office client, I know one of the Office suites applications should not spawn PowerShell or run DLL or CSMTP.exe or MSHTA, those like risky load bins, right? So simple query, we created it and it worked and we were happy with it. And it was, definitely high signal, low noise, low false positive rate. So we liked it a lot. We implemented it, and we developed a process for it. We built some documentation, our analysts to investigate, and we shipped it, and detection was running. Great. 3 months later, 6 months later, our SOC stumbles across an alert. We investigate. It was a true positive. We had detected something weird going on in memory. It was caught. We took it. But during the investigation or the post-mortem of this investigation, we noticed that everything has started with that Word document spawned in PowerShell, but we never got the alert for that. The detection didn't trigger for that typical technique that they use. We caught them later on as they were doing more techniques, executing more techniques. So the question was, okay, what happened here? Why didn't this trigger, right? So we go into the tool and we learned something about this tool that we didn't know. Simple thing, which was like this tool was built to create your own, detection queries. Let's call them watch list. And the tool was designed in a way that if a particular query didn't trigger for X amount of days, the query would disable itself. And I can see how the product team building this tool thought about this and thought about, hey, if this query is not triggering, we should probably disable it at some point. So it makes sense for them. But for us, it made the difference between us detecting something at an earlier stage versus detecting it at a later stage. So that's just one of many, right? Like, and this opened that kind of worms. Like, okay, what else is not working? What other tool has some kind of design like this. And we can expand this to other issues that we had. For example, we had another investigation with the SOC, and as part of the investigation, we wanted to capture a particular user. We wanted to know where this user was logging in from, which computers, which times, etc., in a particular region of the world. And we realized that the logs for this particular region of the world, Windows event logs, were not being sent to our central location. And we identified that it was a broken GPO for this particular OU that was not defining the right audit policy, and we were blind. Everything else was working, but this particular region, we were blind, right? So it also hindered our investigation capabilities, right? I can go on and on, right, on these stories, but what it came down to essentially is that we needed a way to make sure that, one, detections are working all the time, not just from one location, but from any location, right? And I think this making sure that detections are working opens up, a door, and that means, one, is the event pipeline working? Are all your logs being sent to the right place? Two, is your logic working? Because another example that I can give you is one day we found out that because of an upgrade and because of a schema change on our analytics engine, the query that we had, or the detection analytic that we had for a particular detection, broke because the field changed, right? So that's just another example. So if you're not continuously testing these detections, that you don't know if a change or something that happened, an upgrade, broke something, right? So we basically, going back to your question, Matt, I think the problem statement was that we spent a lot of time building detection capabilities, process, people, technology. And once we were at the point where we were deploying detections and custom detections, we realized that we needed a sound process to really test these detections, to make sure things are working as expected, not just from a detection perspective, but also from a process perspective. Is the process, is the playbook being followed every time on each trigger, right? So that's the problem statement, which is like, things are always changing. What if something breaks? We really needed to have a way of making sure that things are working as expected.
Right on. Yeah, those sound like some pretty painful stories in retrospect. But I mean, even though like those were bad events at the time, like sounds like you were able to learn from them very quickly. And like these otherwise like bad events is like sort of what motivated you to really formalize this process. Yeah.
Yeah, for sure. I think realizing that this was an issue that we needed to spend time on definitely evolved into us, going in a route of, different ways, doing our own thing, working with commercial tools, working with third parties, and then ended up at some point during that path, me wanting to build a tool. And that's how Purple Sharp was born. But yeah, we've been a long way, and we've learned a lot, and we've fixed so many things, and we're definitely way better. And if someone listening in is part of a blue team and detection and response team, I highly recommend start thinking about these things if you're not already, because it's the difference between, it could be a difference between a breach and a successful detection, right? Like if you think that you have deployed all these detections, but they're not really working, then yeah, they're pretty much all that effort was in vain.
Yeah. And so if I were to try to summarize that problem statement from like how you look at it, it would be one, sort of the foundation of all this is to have something in place that validates that the event pipeline is working in the first place, because there's a chain of events that has to occur for detection logic to be evaluated, for events to be surfaced in front of analyst eyeballs, right?
Yep.
And without an automated process that's ideally formalized to an extent, then Well, one, like you wouldn't even be able to know if your logic was working in the first place, right? Like
Exactly.
if you don't have that foundation laid out, then you can't even get to that next step, which is ensuring that your existing logic is as robust as it can possibly be and resilient against evasion, things like that. And then thirdly, just the ability to differentiate and like just to have the ability to quickly perform that root cause analysis of identifying what the problem was. Like, was it an issue at one step in the pipeline? No. Okay. Well, now we can proceed and start triaging. Okay. Well, now we can narrow the scope of this incident down to our potential detection logic. And without that automation and formalization of this process in place, what I'm hearing is without the foundation, you can't really work up to a more mature level of quickly triaging what could have gone wrong in the whole process.
Yeah,
Is that kind of accurate?
that's accurate, and I would even expand it. So definitely, if you put it in different levels. So yeah, the telemetry is number one. The detection logic, is right there at number two. But then after that, once the detection logic is triggered, you need to make sure that your like whatever response technology that you use as far as like a ticketing system or how you manage your incident life cycle, that also is another layer, right? What if there's a disconnect between your analytics engine that is successfully maybe running the logic and working, but then an API broke or a password expired or whatever, and then it's not able to create those containers, those incidents for your analysts to pick up. And then one extra layer is, okay, once that's successfully created, are your analysts following the right playbook, right? And I like one, I think it was a talk that Casey Smith did at some point, and it was called Fight Like You Train or Train Like You Fight, right? But then what if, and this is another story, right? Like we develop a new detection. It was a little bit more, AD based, and it requires some knowledge around Active Directory and Kerberos. So we deploy the detection. The detection is working fine. But once it gets to one of the analysts, if they don't really understand what they're looking at, they're not going to know how to investigate it, right? So all this stack of different, like the telemetry, the analytics engine, the detection logic, the response platform, the analyst playbook, the response process, the escalation steps, all this stack, something could break at any point, and the result is no detection, no visibility, potentially a breach, potentially, right? So yeah, like you hit the spot there. Like that's the problem statement. We needed a way to make sure things are operating.
Awesome. All right. So acknowledging the problem, how did Purple Sharp come about as a way to address? Yeah. What's up?
Before that, one question that I always had, and we had many discussions about this, but Red Canary and Keith was one of the first people that introduced me to the detection engineering concept, right? Like applying engineering concept, which is, since then it kind of like changed our program in so many ways by doing this. But I wanted to ask Keith now, so in my experience, as I was building a detection program, we didn't think about this when we were building it, right? When we were defining the data sources that we needed, when we were defining, the team that we needed, the responsibilities, the roles, we were not thinking, hey, by the way, we're going to need detection coverage and QA of the detection, right? We learned that after everything was deployed and, through these stories that I mentioned. But looking at what you guys have built and the awesome work that you do with detection, I was wondering two questions is that how do you, like a general concept question, and I'm sure the audience will like this, is how you guys at Red Canary apply engineering concepts to detection? And second, a specific one is applying those engineering concepts. When did you realize that this detection coverage or detection was working as expected issue was a thing that you needed to spend time and effort on?
I'll take a pass at that. I would love like Matt's thoughts on coverage in particular, but I think the um, you know, I'm not. We definitely didn't set out with designs on like detection engineering, which I think wasn't even really a term at the time, or if it was, it was pretty new. But we were, we were pretty grounded in two things. Like one was like first, definitely like a belief that coverage mattered a ton, right? And like just like that manifested itself really early in terms of like the data sources we chose to use, having a workflow that was largely driven by that was optimized for like actually optimized for a high false positive rate into our analyst team, and like really focused on suppression at that level rather than constant tuning of analytics and trying to keep accuracy high coming into the analyst team, right? So like that was like coverage was very much foundational to like what we knew we wanted to do, right? Like don't miss things. That is job number one. The engineering piece, very much came from the fact that we've just I particularly the early team and even today, like everyone very much thinks about this as a software and an engineering problem, right? And like we look at the people that we have as being like very valuable constrained resources, and we don't want them working on computer problems, right? Like we want them working on like the top few percent of hard problems that we can identify. And so that's those two things, right? And just the need to like achieve really, really broad coverage, and to be able to do it like without having to scale your people linearly, right? With the amount of data or investigative leads you have. All of that just kind of like very organically led us to like, what is today, I think, a super high functioning detection engineering program. But it was very much out of necessity, right? And like kind of like, to steal Matt's words, I start with the problem, right? I mean, we didn't set out saying we wanted to do detection engineering. We didn't set out saying we wanted to do anything in particular other than just make sure that we like find the bad thing before it causes a really big problem. And so that was kind of like the genesis of it, right? And I think from where that bled over into the need for testing, was that being being software people, and just kind of having a lot of heavy engineering background, right? I mean, the fact that like you had to do testing of this stuff, even if it was writing unit tests for our web interface, right? That was also kind of just like very much a part of like how everything worked, and so that very naturally extended over into security operations. The other interesting challenge we ran into was that we by definition, we're looking at endpoint telemetry, right? So we're looking at things that happened on the endpoint, like not so much looking at alerts or things that were blocked or might have happened, right? And so by virtue of where we kind of worked in the stack, we had a really interesting problem, which was that there's really not a great way to like artificially test that system, right? You need to do a very realistic test. And to this day, I'm not sure there's any useful test of the system we operate other than like an actual intrusion and making sure that we find it, or like much more commonly, like really sophisticated customers who do really good testing, or internally doing it ourselves, right? And so, I think that's kind of definitely like, from, I guess from the origin through to today, like not much of that has changed, right? The implementation's changed, but I think like those principles and those problems like still exist today, and like we're definitely foundational and things we're still trying to solve at the same time. So.
Yeah, I'll take it from there. Yeah, absolutely. Like many of those traditional software engineering principles apply 100% to a detection program. From my perspective in threat research, where one of the primary things that we focus on is contextualizing attack techniques through our research and subsequent documentation of them. So that's one aspect which is a requirement for us to start building automation around that in the first place. So our goal is generally when we make the investment in a particular attack technique based on a prioritization model, we would spend the time doing that research. And then on the software engineering side, we're going to want to build a test harness component which abstracts the complexities of that attack technique away for us. And one thing that's really helped us lately was MITRE's transition to sub-techniques, which really allowed us to narrow the scope of our test harness without really getting overwhelmed and really focus on scoping our test harness code really well. So once we've done that, part of the research process is identifying as many variations. You'll hear me refer to them as variations. I don't know if it's like an official term we can coin or whatnot, but the way I look at a variation is even with the advent of sub-techniques, there still may be some variations on any given technique that will likely have a unique detection logic footprint. Take one example that comes to mind, like HTA, right? When we hear HTA, maybe many of us will immediately go to mshta.exe. But a question that would arise is, for me, would be, well, what is MSHTA at its core? Is it just mshta.exe? Or is there a layer underneath the hood of mshta.exe that could be a wrapper for something that is more core to what MSHTA does, which is ultimately execute a script component in the form of like an HTML document, basically. So that's the essence of what we want to try to get at when we threat research at Red Canary talk about detection coverage, is identification of all of those technique variations and to then translate those into code in a well abstracted way that any end user, primarily internally at the moment, could consume and start exercising very easily without being a subject matter expert on the attack technique, all of those identified variations. And what we build on top of that are the actual tests. So something that is foundational to our team, so like you mentioned, validation of the event pipeline being foundational to operations for threat research. So what is foundational to us is when we're asked, can Red Canary detect technique X? Me not necessarily being a subject matter expert on that specific technique, my initial answer is almost always going to be, I don't know. But the first way that I and our team will chip away at addressing that is by first answering, can we see it? It sounds really simple when I say it, but I have to remind myself of that regularly so that I don't feel overwhelmed and I could come back to a place of reminding myself like, okay, let's think about the scope of the problem, identify those variations, build code on top of that, write the tests on top of that, and then we have an automated process to validate whether or not we can see that technique in all of the identified variations. And only then, well, with exceptions, only then can you like really confidently say that you detect a technique because you can see all of its identified variations. Yep. And there may be behaviors and whatnot on top of that, but can you see the technique is the foundation that can really build your confidence in can you detect a sequence of behaviors, which I view as a layer on top of techniques.
Yeah, I think that essentially describes, going back to your question, what Purple Sharp tries to be, right? And basically what Atomic Red Team also tries to do, right? So having defined those problem statements, what we realize is that, hey, we need a way to on demand execute adversary techniques in a flexible way, in an automated way, so that we can, because executing this technique will validate all these things: pipeline, detection logic, response process, escalations, everything, right? So you need that attack telemetry. You need that behavior. So that's what Purple Sharp is. And I want to start with a quick demo, just to kind of frame things. So you guys, let me know if you see my screen here.
Yep.
Okay, real quick. So going back to what Matt said, let's create a scenario, and let's say, okay, what if your CISO, your boss, your stock manager, he looks at the 2020 threat detection report from Red Canary, and he sees as #1 process injection, right? And like, this is the technique that Red Canary has seen the most across their customer board. So he looks at you as like, okay, where do we start? And going back to what Matt was saying, okay, if you're not all of us really understand, memory and how a process is, how you execute code in a remote process. So, it's not simple. So where do you start, right? Like, how can you answer your boss and let him know if we have coverage, we don't have coverage, we, need to buy something, we need to deploy something. And it all starts by simulating it, right? By running it against your environment, right? So the first things that you may do is like, okay, okay, what should I do here? Where do I start? The first thing you probably do, if you're just like me, I'm just gonna do this, like go to Google and see what you find. You probably find this, which is great resource, of course, and with the sub techniques even better. So you learn what these things are, but then let me give you an extra step. Let's simulate these techniques with Purple Sharp, right? And we're gonna simulate 3 techniques. With Purple Sharp, we're gonna simulate them locally. So on a host, we're gonna run the Purple Sharp binary. So I'm gonna share my screen. Do you guys see the video?
Looks great.
Okay, great. So you're on Purple Sharp, you get of course we need a banner, right? A cool ASCII banner. So let's look at what we're gonna do here. We're gonna execute 3 techniques, 3 process injection techniques. The first one is the PE injection, so the typical create remote threat. Second one is threat hijacking, and the third one is APC injection. Okay. And we're going to add an extra parameter called PB sleep, which is going to sleep 60 seconds between the execution of each technique. Okay. So we run those, and I think I'm going to fast forward here. So as you can see, Purple Sharp, what it does, it starts Notepad and then injects to Notepad a shellcode that in the shellcode, all it does is just a ping, right? So it's doing the first one, it finished the first one. So I'm going to fast forward so we get the results. There you go. And let's look at the results. So it gives you a header. I'm starting this technique on this host. At the time, you can see that there's a technique executed every minute, roughly, a minute from each other, right? So for the first technique, we see that Purple Sharp first starts a new process, Notepad, and then injects to it. It first calls, open process, virtual alloc, write process memory, create remote thread. Those 4 API calls that give us process injection, right? Then for the second technique, it starts a new Notepad process and runs a different set of API calls. In this case, suspend thread, set thread context, runs. And then for the last one, it's a different set of API calls, queue, user, APC on each thread, right? So now that if you are in this scenario, let's say going back to the Matt's question, can we even see this, what happened here? So we look at here, this is Sysmo events, by the way, and we see here that Purple Sharp runs. It starts Notepad, as you can see, at 6:20:29 or 20:28, around that time. Then we see Notepad being created, and then at 6:20:30, we see several events. The first one, if I start from the bottom, is we see a event 10 process access. This is when Purple Sharp was getting a handle to Notepad and overriding its memory with the shellcode. And then we see a ping running because create remote thread was called and ping run. And we see event 8 here, create remote thread. So Sysmon can easily detect create remote thread, right? Which is good. Now we know this. Maybe we didn't know this before. A minute later, something similar happens, but this time all we see is the process access, event 10. Purple Sharp getting a handle to notepad.exe, but we see the ping, but we don't see any other event. And for the last one, it's going to be the same, right? So one thing that we learn is that, one thing is common across these three techniques is that if you're looking for event 10 on Sysmon, which is process access, then you'll see Purple Sharp got a handle to Notepad and injected data or shellcode into it with the event 10. Unfortunately, event 10 is really noisy, right? So what are the takeaways of this scenario? If you're a geek like me, you've learned new Windows 32 APIs, which is cool. But the first thing that you may ask yourself is, you probably have a prevention control in place, right? An AV, an anti-malware, next-gen anti-malware. Did your tool pick this up? Did it prevent it? Did it detect it? Or was it like in my environment that everything just ran? Like, that's the first thing that you're going to learn, right? Is your vendor really doing the things that they're telling you that they do, right? The another thing we learn is that it's easy to detect P injection with Sysmon. All you need is event 8. Of course, in a production environment, maybe event 8 generates a lot of data. So in which case you'll have to do your tuning, but that's part of the detection process, right? But at least you can see it, like Matt was saying. And the last one is, we don't have, at least Sysmon doesn't have specific events for the other two types of injection. So you may either, need to go somewhere else. Maybe you need a commercial tool, or how important is it for you to detect these techniques? Are the threat actors targeting your company using these techniques? Well, at least you have an idea, right? So having started from a Google search into executing 3 ways in that environment and comparing to what you see, I think brings you a long way. So that's the first demo that I wanted to show you, how Purple Sharp can help for a security organization.
If I can jump in real quick too, like as you were talking, Matt, and kind of just explaining kind of how you think about coverage and how how your team approaches that, and then Mauricio, this kind of demo kind of dovetailed perfectly. And I remember reading about Purple Sharp for the first, or seeing it the first time, and then reading more about it when you updated it pretty significantly a couple months ago. And it's super interesting because there's I know personally, I've, I think, fallen into the same trap that a lot of people fall into when you say things like detection coverage, which is just detect a lot of things, right? And I think Matt, the way you talked and think about it, and I think Mauricio, the way you've implemented it, if there's a huge lesson and takeaway, and for me in particular, it's that detection coverage can be as valuable or even more valuable if you're looking for fewer things with a lot of depth and understanding, right? And I think when you look at stuff like process injection being a really good example, right? It's an operating system feature that the operating system and applications can't live without, so you can't get rid of it. And there's a ton of depth and complexity there, and it's just really neat to think about that, where would you rather have coverage? This is kind of open philosophical question, right? But would you rather say we're looking for 90% of all the MITRE attack techniques, or would you rather say we're looking for the 10 or 20 most prevalent, impactful, and we understand them really well, right? And I think that's so super cool, and not often enough, not often discussed way of thinking about it, and in particular implementing and testing coverage. It's really cool.
And there's certainly a cost benefit analysis that has to occur when making that kind of assessment too, because I mean some of what I refer to, it's a relatively slow, expensive process to go to that level of depth to get that level of breadth of technique coverage, right? So we try to prioritize accordingly, and things like the threat detection report and other metrics can really help prioritize accordingly. I mean, process injection being super important and prevalent to have decent coverage for. So man, I feel like we could talk for hours on this. I have so many questions. Why don't we start briefly, if possible, as you're going through the demo, I have a hard time like removing my attacker hat, thinking like how a detection engineer might think through perhaps creating naive detections around you just running those static tests. And so maybe they might go look at your code base and be like, oh, like I can tweak these inputs and potentially circumvent all these detectors. Like, how do you, I guess coming back to coverage once again, like how do you think about that? Because I really liked what you were talking about at B-Sides Charm, because I think you covered this topic really well when you were talking about your specific example of using, was it password spraying?
Yeah, password spraying.
Yeah.
Yeah. I think I mean it definitely, like you said, you have to do a cost analysis because especially depending on how big your team is, having one person spend like hours or a full FTE just like looking at all the ways that techniques are executed may not be possible, right? So you need to define what's important to you, and we define what's important to us specifically around Active Directory attacks, for example, because that's one of the things that we knew. For example, in our case, like there wasn't that many commercial tools providing a lot of detection capabilities around that. And one example is password spraying, right? And I can talk a lot about that. For example, there's a lot of ways that you can do password spraying. One is, imagine the scenario that your host is infected, or user is infected, and in order to escalate privileges or maybe move laterally, he needs some extra creds. So he'll do a quick password spray attack. So from that perspective, if they're using let's say like something like PowerShell Empire or a native tool, what's going to happen is the password spray is going to use Kerberos for the authentication, and what the event is 4771, right? So you can easily detect password spray with 4771. But the next step is like, okay, but what if the attacker chooses not to use Kerberos and uses NTLM? Oh, okay, well that changes, because now in order to detect password spraying, you need to be logging NTLM failed authentication events on your domain controllers, which is 4776. Like, okay, great. But then what if the attacker doesn't want to password spray against your domain controller and rather just picks a server that that's sitting there and sends SMB requests to authenticate with a domain account to that server? Even if he's not an admin there, he can still password spray against a server and not a domain controller, right? So that looks different on the logs. And then the last step, what if the attacker decides to spray 100 users, but instead in assuming that you build logic to detect this type of one IP or one user and many user authentications, which would allow you to identify this, what if the attacker sprays the authentication events across several hosts so that it's only 3 per host or 1 per host? That looks completely different on the log. So that's what I talked about at B-Sides Baltimore, and I wrote a small tool which was kind of like the predecessor of Pulper Sharp. So yeah, but again, you need to pick those battles. Where are you going to focus on that detection coverage and trying to identify all the ways, or maybe a few ways of the technique can be executed? Because you may find yourself, it goes back to the attack MITRE problem, right? Like, I think I always hear, it's Bryson Board, he always says, attack is not bingo, right? So like the same is here. I think applies here. Detection coverage is not bingo. You cannot, I don't think you must say, okay, I have this one, I have this one, I have this one, next. I think you really need to understand your threat model, understand your attackers, and really focus the effort where it makes has the more return of investment.
Yeah, absolutely. So trying to read between the lines of just hearing your thought process, in this case about password spraying, picked up on a couple things. Would you agree that more effective evasive adversaries tend to, or perhaps have a background in detection engineering themselves?
If they not, they should now. Like
yeah.
If they don't, they should now, I think. And
Totally.
the same goes for detection engineers. Like we need, as detection engineers, we need to understand how these techniques are executed, right? Which is
Yes.
why my tool is also a way to expose those API calls, for example, because you can just go to GitHub and copy paste the code, and the same thing what Atomic Red the team is doing, right? Just like copy paste the code and test it yourself, or change it yourself and see what could an attacker do. But yeah, totally. I
Yeah.
think that the purple is definitely a big part of this.
Cool. Yeah. And then the other observation is like from the flip side, in a detection engineer's ability to apply an attacker's mindset, it can allow you to identify what mutable or like controllable inputs an attacker has into an attack technique. So when you understand the technical components that underlie that technique and have a sense perhaps of how a detection engineer might iteratively develop detection logic, then as an attacker, you can really start to identify like what mutations to that input or variations of the technique could be achieved. And just through that whole iterative process, you can like gradually chip away at building that confidence in stating that you have good coverage of a technique. Because like you said, like Bryson has always said, like these aren't checkboxes. Like checkboxes like on the matrix, like that there is no like black and white. It's either 100 or 0% coverage. Like there are various shades of gray, and we're trying to get as close as possible to that 100%, but acknowledging that we will never get there. There's probably always going to be new variations and just new just new things come up all the time. So
I want to ask, like, there was an implementation question that we talked about before, and I think it definitely goes like right to the heart of kind of this like way of thinking about coverage that is like very like that's as much depth in one area as it is like breadth across like a whole set of problems. And then I think also just kind of like was one of the things that I related to Purple Sharp that I kind of like jumped out at me right away in terms of like design, or at least like, you know, the ability to do this with Purple Sharp. So yeah, wanted to kind of get your read, you know, when as defenders, right, it's super easy. Like you're sitting here rattling off like event IDs, and even on the behavioral side, right, it's really easy to say, hey, like relationships between processes, like an injection, like a set of requested access permissions from like an injection request, right? Like there's these kind of like crutches we rely on as analysts, sometimes subconsciously, but like they're things that serve us well for a long time. And if you're an adversary, like, you know that, and you'll let people catch you for some period of time before you kind of do the end run. And so, yeah, would love to understand, you know, when you design Purple Sharp, you know, obviously like you're going for depth here, right? And like it's really well suited for that as a tool. It's kind of curious, like if you don't mind just kind of like educating everybody on like a couple of those common crutches that you've seen, whether it's like tools or teams or just testing methodologies, like kind of always go to the well on, that, you know, like you can make kind of look hard, but you also know like are kind of your secret weapon for finding things. Like what are some of those techniques that you would prioritize evading, or have you built any tests in Purple Sharp that are really focused on kind of breaking some of that?
Yeah, that's a good question, and I think I can share some slides on the design of Purple Sharp that actually speaks about that, and we can go to the last demo as well. So once again, I'm going to share my screen, and let me know if you can see this.
Yeah, I see it.
Cool. All right, great, guys. Thank you. Okay, so yeah, so Purple Sharp, right? So I'll tackle your question in a little bit, but let me just frame it up. So what I needed was a way to execute techniques on remote hosts, because I wanted to stay away from running simulations from the same fixed infrastructure that would, my SOC knows, oh, this IP again? Okay, that's the simulation test they run every day. So you're not testing really the response process, right? Or is it coming from this test user account? Oh yeah, okay, this is a simulation again, I don't care. So I really needed to break that gap between running simulations from the same infrastructure, from the same IPs, to be able to run simulations on real hosts, right? On remote hosts in my environment that were actually, we have real users, real data, real process tokens, right? So one of the requirements for me was to deploy simulations in remote hosts, right? That was a big requirement. And for that, I built this little architecture that you'll see here. So I have 3 modules of Purple Sharp. One is the orchestrator, which runs from the computer that you're running the simulation from. Like, let's call it the operator computer. So the orchestrator, then it uses Windows administrative tools, services like WMI, RPC to run something on remote hosts. And the first thing that runs is the scout. The scout, what it does is just gather some data from that host, specifically the user who's logged in, the process ID of Explorer.exe, sends that back to the orchestrator. The orchestrator uses that data to stage the simulation, and then the simulator runs to actually execute the techniques. So going back to your question, Keith, one of the biggest things I think that analysts rely on is the parent-child process relationships, right? And I needed to break away from that, because if my simulation deployment was being caught, then the simulation itself, it doesn't matter, right? So I really wanted to focus time on figuring out ways of separating that simulation deployment from the simulation execution. And this is what I came up with, the scout and the simulator. And the other thing that I also come across is, the first versions of Purple Sharp, they would use the command line to define the techniques, right? So when I was testing the initial techniques, our SOC was catching me because they saw that the simulator had /T1086. Oh, this is attack MITRE ID. This is probably a simulation tool, right? So I needed to get better. Then they were catching me just by the metadata of my file. It says Purple Sharp, and they Google it. Oh, Purple Sharp is an adversary simulation tool. This is a simulation. Oh, so there was it was so interesting. For a few weeks, I was running a simulation, getting caught by the SOC, adding a feature, writing a simulation, getting caught, adding a feature, writing a simulation. And finally, success for me was when the SOC caught the simulation itself and not the simulation deployment. And although they were good enough to eventually work their way back and catch the simulation deployment, I'm fine with that, as long as what triggered their eyes, what had them open an incident, was the simulation itself. I'm good with them finding out that at the end of the day, this was Purple Sharp, right? So I got that to that point. So this is
Can I just say, Mauricio, I know I'm such a nerd in saying this, but that's such a heartwarming story to me. I love hearing that. It's so easy to claim that the SOC or the blue team was gaming you that whole time.
Yeah.
But through that whole process, they were improving to the point of the objective that you sought in the first place, which was detecting the underlying techniques. That's just so awesome and good to hear.
I had fun while doing that. So here's just how Purple Sharp works, but I'm gonna just jump to one of the key things. For example, I use SMB, the protocol, to upload these modules. And why do I use SMB? Because I learned that if my scout process would drop the simulator to disk, then the SOC would easily, when they catch it, the SOC would easily say, hey, okay, I see this weird binary. Who dropped it? Oh, and that was the relationship between the scout and the simulator. So that way I use SMB so that there's no relationship, the scout doesn't drop the binary, and SMB, the kernel itself or the Windows SMB service, drops the binary. I use WMI for remote code executions. And here's a challenge with this. If you deploy something to WMI, then the parent process is also known, because it's always going to be WMI PRBSE.exe, right? So that's one of my first challenges that I didn't discuss yet. The SOC was catching me because my scout was always running as WMI, as a child process of WMI, and they were saying oh, this is WMI lateral movement, so I caught you. But then I added the parent process ID spoofing, that would break the relationship between the scout and the simulator. So the simulator will run under as a child of Explorer.exe and not WMI. And then I added name pipes because the stock was catching me through the command line. So I just added like a mini C2 communication between the scout and between the orchestrator and the simulator, where this information, the techniques, the parameters are passed to a name pipe. So now no more command line, right? And what it looks like to an analyst is like this. You know, you see the scout running as a child process of WMI, but then you see the simulator running as a process of Explorer, right? And with a name like invoice and running under the context of the user, because using the parent process ID spoofing technique, I not only get to break the relationship between parent and child, I also get to execute in the context of the logged user. And this is really powerful because now the SOC will see a real user, that they can investigate. So I can ask the SOC, okay, as part of the process, hey, tell me every time a user has logged in from the VPN, that user, because it's a real user. If it's a fake user, we won't have that data and they cannot search for that, right? So this takes me to the last demo real quick. I know we only have a few minutes. And Purple Sharp executes playbooks, and I'm gonna execute three playbooks. I'm gonna use Visual Basic, Network Service Scanning, Network Share Discovery. I'm gonna simulate Mimikatz and Windows Remote Management for lateral movement. So real quick, in this case, now we are not defining to the command line, but we're using a JSON file to define what the simulation is going to do. I can define the host I'm going to run it against. I can define the scout, the path of the scout, the path of the simulator, the techniques, how much time I want to wait in between each playbook, between each technique. So really flexible, right? So then I'm going to fast forward here. You run it with the parameter. It's going to ask for the parameter, your password, and it's going to execute techniques against these remote hosts. In this case, the Visual Basic, network scanning, and network share discovery. Now, one cool thing about the first one, for example, is that we run this simple W script, which is a fake. But then here's a cool thing. Because I'm running under context of that user, I can impersonate his token and do LDAP queries to the domain, and then identify hosts that I can scan. So in this case, it's like random, right? I'm scanning real hosts on that environment randomly. The same goes for this network share enumeration. I do an LDAP query from that user, and I do network share enumeration on this host, right? So like this is the requirement that I was looking for. I want to run simulations in the context of another user on a real computer and show the logs that that infected user, hacked user, like spray the network and do things like authentication, like lateral movement. And I'm going to fast forward real quick here. And if you have the results are also a JSON file that you can ingest, right? So you can ingest to your tools. And if you are, sophisticated enough, you can ingest this to your detection tool. And you can have something like this, where you're constantly mapping. I run these simulations, and here are the events that trigger from those simulations. Like in this case, this is a network scan. This is VB script. This is the lateral movement technique. Anyway, I'm going to fast forward here. I'm going to share the links for this. But this is the end goal, like continuous end-to-end adversary simulation against your environment to make sure that things are working as expected.
Incredible. That's awesome. So one of my takeaways here was, reminds me of a quote. I think it was from Jeffrey Snover at Microsoft, who said, security is not something to be solved, it's managed. And it sounds like the best way for us to sharpen our tools and processes to gradually improve our security program is not by solving everything at once. It's through an iterative process, right? So you getting caught, you getting quote gamed for all of these techniques that were being used. I don't see it that way at all. I see it as the gradual increase in detection coverage.
Yep.
in a collaborative fashion too, with really good automation on top of that. And it's such an awesome like harmony of like people and process, and it's really great to hear. And I really love just how much passion you have for this, and just how much like formalization and thought you've put into this process. We're running up on time, but I want to ask one last question. If you can't address it in a minute or so, then we can maybe save it for another time. But what would you say is the primary difference between Purple Sharp and, let's say, your SOC wanted to do something similar for exercising detection coverage and event pipeline validation? Difference between this and like a red team framework like Cobalt Strike?
Yeah, that's a great question. And I guess the main difference right now is that Purple Sharp is not weaponized in the sense that, it can do a password spray attack. It can do Elsa's dump, but it won't leverage the results of that, and it won't provide that back to the operator. But I absolutely think that you can test your controls, you can test your detection coverage or enhance your detection coverage with red team build tools. And actually we started that way. We started using Empire, Posh C2, Cobalt Strike. Where we hit the kind of like the wall was some of them don't have rich APIs, and for continuous testing we needed rich APIs. Now some of them they do, like Empire, Faction C2, some of them they do, so they can be used. I guess the second limitation was that if you decide on using a C2, you're always going to be constrained by by the design of that C2. Unless you're building your own C2, like if you use PowerShell, okay, Empire, it's going to be PowerShell. If you use, Metasploit, it's always going to be native and reflective DLL injection, right? So you cannot change that unless you go in and change their code. So I feel for me, the answer is I think they can definitely be used for adversarial simulation, for detection coverage, testing, but ultimately you're going to find some limitations like I did that led me to kind of build my own.
Cool. So overlap definitely exists, but perhaps there's just a slightly different set of requirements.
Yeah.
That say we would have for detection coverage validation versus adversary simulation that like a red team would engage in.
Yeah, I agree.
Different outcomes and objectives as well.
Different objectives, but like, same techniques, same, TTP ways of executing it for sure.
Right on. Cool. Well, I appreciate that. Yeah. Any last minute thoughts, questions you have, Mauricio?
No, it was really good to be here. Thanks a lot, guys. Yeah, for audience, let's think about when was the last time that you confirmed that your detection for XYZ technique is working? Just think about that and think about the ways that you can make sure that things are working, because otherwise that may happen, and the worst, like the law, following Murphy's laws, it's going to happen in the worst day when you'll find yourself scrambling. So let's better prepare for that.
It's an amazing reminder. Sounds easy, you saying it, but putting it into practice is another issue. And we thank you for helping bring this to the table, articulate it really well, and allow us to think through that process of actually implementing this within our environment. So thanks so much for your time, Mauricio. Really appreciate it. Always a pleasure seeing you, buddy. And Keith, thank you as well. Yeah, this was a ton of fun.
I feel like we need another hour, but thankfully we've got plenty of Fridays coming up. So
there you go. We'll do it. We'll do it again. Yeah, thanks a lot, guys. This was really fun, and good to see you again.
Yeah, and audience, thank you for your time. Everyone, happy Friday. Have a good, happy, safe weekend.
Take care, guys. Bye all. Thank you.